Hey guys, hello everyone. This is Miss Samara. I'm back with my next lesson. I hope you guys are enjoying your forced break. And trust me, guys, I miss you guys so much. But, anyways, yeah, so let's just move on to today's lesson. Now, you guys might be wondering about how come this background looks so different today? How come we have a grid instead of blank notes? The reason we have a grid with a graph paper on it, graph on it. The reason we have that because today's topic is something you always love to do. No, you guys don't. I know that. So we're going to be doing graphing. So we're going to be learning about graphing. So first of all, let's just talk about the section. I'm on 7-5. No, yeah, I know your question. You might be wondering about how come we skipped 3 sections in there. Now the reason, actually not 3, we skipped 4 sections. So we're going to go back to those sections at the end. So I thought about doing 7-5 first because that's kind of similar to what we are learning about right now. So it would be easier for you to do that transition. So I'm on 7-5. It's on page number, it's 623. Before we learned about solving system of equations, but now we have system of inequalities. Again, just like the last time I told you, it's not just linear inequalities or equations. You get to see non-linear inequalities too. So you'll see linear and non-linear both. So when it comes to inequality, let me just give you kind of heads up on that. So I hope you remember, I always give this example. So let's say if I say x is equal to 3, it's an equation, means x is exactly equal to 3. But when I say x is less than 3 or bigger than 3, it's not just one solution. This is where we graph. If it's less than 3, so you know everything less than 3 would be your answer. If it's greater than 3, so you know it's going to be everything bigger than 3. So it's not one exact solution. You'll see a whole section on the graph. So I guess you might have just got the clue here. So in order to do system of inequalities, you gotta use graphing. And later on, we're gonna be shading that. All right, so in order to understand system of inequality and graphing, first you have, just because we have linear and non-linear both, so first thing you need to understand is how to graph all different type of functions. Even though I assume you guys should know that from your previous math courses, but it's okay. I'm down to review that, okay? So first, let's review graphing linear inequalities. Trust me, guys, this is the easiest thing. You should know this, okay? It's going to be a quick review. So linear inequalities. How do we do that? So first of all, let's say I have, my function looks something like this. 2x plus y, and it's greater than and equal to 3. Okay, in order to graph this linear inequality, first you have to make this equation into slope-intercept form, which is y is equal to mx plus b. So it means you need to isolate this equation for y. So I would, let me use a different color. Let's see if it still works on graph. Yeah, I guess it should. If I add 2x, so my equation would be y is bigger than and equal to 2x plus 3. And don't forget, we switch the sign if we divide or multiply by a negative. So anyways, this is my equation. Inequality. So this is the one we're going to be graphing. And how do we graph? So let's start off with my y-intercept. This is my y-intercept, which is at 3. So let's just say, let's go by 2's. So this is 2, this is 4, this is 6, this is 8. So I would start off with 3, which is here. Then slope is 2 over 1. So it would go up 2 over 1. Up 2 over 1, up 2 over 1. Let's say if I want to take few points opposite direction, then I would go down 2 over 1, down 2 over 1. And then you need to decide if it's dotted or solid line. How do we do that? It comes from this sign. If there's a line under, it would be a solid line. If there's no line under, I'm just going to write it down. So if it's just equal, greater than or less than sign, it would be a dotted line. If there's a line under, then there would be a solid line. Okay, so once I have my all these points here, so I need to draw the line. It's going to be a solid line, so it's going to be something like this. But that's not all. You still have to decide what area you need to shade. So you need to shade. How do we shade? This is where we take a testing point. And the easiest point you can take is 0 and 0. 0, 0 is here on this side. I need to plug 0, 0 back into my original equation, which is this. So let's plug it in for both x and y. Plug in for y, it's 0 greater than 2 times 0 plus 3. Let's simplify. 0 is bigger than 3. Is 0 bigger than 3? No, it's not. If this statement is true, then we shade it towards 0, 0. If it's false, we shade away from 0, 0. Since 0 is not bigger than 3, so I need to do the opposite side. So this whole area would be my answer or my solution. That's my first example. All right, move on to second one. So pretty simple. Let's say I have x is, what did I do? My bad. Next example, I have x is less than and equal to negative 3. Just that. It's x equation, means it's going to be just a vertical line on the graph. So negative 3, I would say here, it's a solid line, so its x means it would go something like this. Almost there. Now time to shade. How do we shade? We need to, for something like this, you don't have to take a testing point. If you want it, you can still do that. But what I'm going to do is I'm just going to look at the line. X is less than negative 3. So less than negative 3 would be this whole area. So that would be my answer. All set. Or you can just plug in 0, 0. That could be another way. That was my second example. Now next example is circle equation. Oh, what I'm doing? I don't know. I'm sorry, guys. I guess I'm just hitting something accidentally. So let's say if I have to graph a circle. And I hope you remember from first chapter. Yeah, we did circle graphing in first chapter. So circle graphing this is where you see x and y both square. And it would be equal to radius square. If there's anything attached with x and y, that's just going to be the center point. Like here, I see nothing attached, like there's nothing added or subtracted to y. So the center point, I'm really sorry, guys. I don't know, something that's kind of glitching. I don't know. So it's 0, 0 for the center point. And the radius, oh, my bad. Let me just put numbers in here. Let me just cross this off. Let's say my equation is x squared plus y squared is equal to 25. So there's nothing I have no clue what's happening. I'm sorry. There's nothing added with x and y. So pretty much center point would be 0 and 0. And the radius, this is r squared. So my radius would be 5. Let me show you one more example. Let's say I have x minus 3 squared plus y squared and it's equal to 16. So there's something added with x. So that would change the center point. So it's always going to be the opposite of this number. So the center point for x-axis, it would be 3. There's nothing added to y. It would still be 0. And the radius would be 4. Let me show you how to graph these. So let's say... Let me just make it into inequality. Let's just say this is less than, just less than. So in order to graph, I would start off with my center point, which is at 0, 0. And from there, I would go for 5 units in all 4 directions. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. And then once I have it, I'm just going to connect these points. Hold on, is it solid or dotted line? It's going to be a dotted line because there's no line under. Let me fix that. So it's going to be a dotted line. So basically what we do is we start off with the center point, and then from there we go by the radius number in all four directions. Now finally we need to decide what area to shade. Again, you can take a testing point. So the testing point, I would pick 0, 0. Let's plug it into the original. If I plug 0, 0 into original, so 0 square plus 0 square, and it has to be less than 25. So 0 is less than 25. Is that correct? Yes, it is right. So it means since 0 is less than 25 and 0, 0 is inside the circle, so I would shade it. I would shade inside area of this circle. But let's say if it's false, then I would shade outside this circle. All right. So that was the circle one. Now the last example I have left is quadratic. How do we graph? I know this video is going to be a little bit longer. So how do we graph quadratic? I'm so bad at spelling. How do we graph quadratic functions? See, same thing happened again. How do we graph quadratic functions? So quadratic function, this is where you see a parabola with a vertex down here. It could be like this, then the vertex going to be the max number. So the idea is vertex is the middle point, and first you need to find the vertex. And in order to graph, we need to make a table after. So how do we find vertex? So in order to find the x coordinate of this vertex, we do negative b over 2a. And to find the y, we plug in this number back into original to find the y coordinate. And rest is pretty much writing this number in the middle, 2 numbers to the right, 2 to the left. Okay? Let me show you this example. I have y is less than x squared minus 6x plus 10. This is degree 2 function, definitely going to be a parabola. But first, let's start off with vertex of this function. Vertex is negative b over 2a. So negative 6 over 2 times 1. Simplify. 6 divided by 2, which is 3. So the x coordinate of this vertex going to be 3. So how do we find y? Excuse me. How do we find y? So for y, you need to plug this number back into original. So let's plug it in. So 3 squared would be 9. 6 times 3 is 18. And plus 10, I have 1. So this is my vertex. And once you have the vertex, the rest is pretty much making this table. We write vertex in the middle, so 3 and 1. Then we take 2 points to the right, which is 4 and 5. 2 to the left, I have 2 and 1. And we need to complete the table. I hope you remember this. How do we complete this table? You need to take these numbers and plug it back into original equation, and you need to solve. Okay, I already have these numbers down. So I have 5, 2 here, 2 and 5 here. Let's graph. If I graph this, vertex is 3 and 1 here. Then I have 4 and 2, which is here. 5 and 5. This one here, here, and here. Okay, dotted or solid. So you need to look at this sign. There's no line under, means it's going to be a dotted line. Once I'm done graphing, time to shade. How do we shade? Again, I need to take a testing point. So the easiest one is 0 and 0. If I plug 0, 0 back into my original, 0 for y, 0 for x. Let's see what happens. If I simplify, this would be, I need to erase this thing. Okay, so if I plug it in, so I have 0 is less than, okay, this would become 0, 0, 0 is less than 10. Is that true? Yes, it is true. So since this works, so I need to shade it towards 0, 0. So let's try locating 0, 0. So 0, 0 is outside this parabola, which is here. And it works for this function, so I need to shade it towards this. So instead of shading inside the parabola, I would shade, let me pick a different color. I would shade outside the parabola. So that would be my solution for that. And yeah, this is pretty much all. So if you need help on any of these examples, you can just put a comment and I'll try answering that. And yeah, stay safe and thank you for watching. Bye bye, guys.